Hi, everyone. Welcome to Astro at Home, lesson number 18 already. We're finishing our 4th week. We will continue next week. I just want to let you know right away that we are taking a 4-day break. So no Astro at Home tomorrow or Monday, but then we'll be back on Tuesday for sure. We have speakers lined up for many more weeks. So if you're new to Astro at Home, I think most of you are regulars at this point. But if you're new, my name is Julie. Today, Lindsay is hiding in the background, moderating the chat and sending me questions because I'm presenting today and I'm going to be talking to you about Pluto. Hold on. There we go. Pluto. If you have questions, I see there were lots of questions already being sent in the chat. So again, you can ask questions in the chat on YouTube. Please try to keep the chat for questions. It makes it a lot easier for Lindsay in the background to copy and paste questions. We do have to block people sometimes if you're spamming or sending things that are not supposed to be there or repeating the same thing over and over. So please remain polite and avoid spam and ask questions. We love questions. We like that you're curious, and that's why we're presenting many things. Oh, wow. Lots of questions already. You know what? I'm going to start by presenting a bit about Pluto because I know I'm going to answer many of your questions during my talk, but I will come back to some specific questions a bit after. So I'm going to talk to you about Pluto because Pluto is fascinating. It's a very interesting world in the solar system, but mostly people ask me the same question over and over again. Why is Pluto not a planet anymore? So let's talk a bit about that first, and then we'll have a look at the recent images from Pluto, and it's very beautiful. So let's start with, what is a planet anyway? I won't, you can type something if you want. I won't see your answers, but think about it for a minute. What would you call a planet? What is your definition in your mind? And well, let's see what the definition is. Actually, the name planet means wanderer in ancient Greek. And I'll show you why they're called wanderers. I did make an animation here. This is using Stellarium. We'll put the link again to Stellarium in the below the on YouTube in the links below. If you click on the plus, you'll see we put lots of information underneath each video, so you can go back and look at different sites. Okay, so this is Stellarium. It's a planetarium software, so it shows you the sky tonight. I actually set it up so that this is tonight. Oops, well, I'll hide my cursor. This is the 9th of April at 8:30. So 2030 is 8:30. So you can see in the western sky, we're looking in the western sky here, southwest. We have some stars. Betelgeuse is a very bright star. Rigel, Sirius is the brightest star in the night sky. But what if you did look in the last few days, and if you look again, what you'll see is the bright Venus. So Venus is obviously a planet, but it reflects the light from the sun. But when we see it in the sky, it looks like a bright star. So just imagine you don't know anything about Venus or Betelgeuse, which ones are stars and planets, and just look at how it moves from day to day. So I'm going to play this video here. And what I'm doing is I'm increasing day by day. So we're seeing the sky at 8:30 every night and just changing one day at a time. So you saw the moon just move by. That was at the end of April. You saw that everything moved. Now in May, it's going to be much brighter at 8:30, but let's play that again. Just notice what Venus does compared to the rest. You might see that the stars all shift towards the horizon, but then Venus moves differently than the rest. So if you go back thousands of years ago, people didn't know much about the sky, but when they looked up, they noticed that there were some points of light that were moving differently than the rest night after night. And that's why they called them the wanderers. So there were points of light that were different. Now we know they're planets. They are much closer to us than the star. They're in our own solar system. And the fact that they appear to move like that is because everything is moving around the sun. So we're moving. They're also orbiting the sun, the planet, so they appear to move relative to the background star. So that's where the word planet comes from. And for a long time, that's how we knew planets. Now we know planets. I mean, if I show you a big picture of Jupiter like this is, you might say, well, obviously this is a planet. You know, it's a big round object and it goes around the sun. It's in orbit around the sun. So we're used to seeing images of like Jupiter or Mars. Beautiful image of Mars here. Now that we have telescopes, we can learn a lot more about them. We've sent probes to these objects, so that's why we have a lot more information as well. We've sent probes to some of them, not all of them. But what if I show you this picture? Is this a planet to you? What do you think? Well, this object is a complicated one. This one is Ceres, and you might not know about Ceres, but here's a bit the history of how we named it. I told you that we could see planets in the sky as, wanderers, so they're moving points of light. Now that we use telescopes, we can see more moving points, and we've discovered many of them like that. So Ceres was discovered in 1801, and it was a point of light that was moving relative to the stars. We named it a planet, but you've probably never heard of Ceres as a planet, right? Because around 1850, so for those 50 years, we discovered many more objects, many more what they call planets at the time, wandering points, and they were all between the orbit of Mars and Jupiter. So we realized that there was this asteroid belt, right? There was this belt of smaller objects between the orbit of Mars and Jupiter. So we call them asteroids. And then Ceres lost its status of planet and became an asteroid in the asteroid belt between Mars and Jupiter. So its name changed. It doesn't change anything to Ceres itself. It's just the way we classified it. Then in 2006, its title changed again and it became a dwarf planet. So I'll tell you why in a few more minutes, but let's compare that with Pluto. So this is our beautiful Pluto. Pluto was discovered in 1930. It was named a planet. It's a few thousand kilometers across. We know it was very far in the solar system, but we did name it a planet. But then about 20 years ago, so still very recent, we realized there were many objects with similar orbits in what we now call the Kuiper belt. So it's a bit like Ceres, right? We found Ceres first, then we realized there were many objects like that, and then we call them asteroids. So we found Pluto. Then around 2000, we started finding more and more objects in the Kuiper belt, and we found some that were almost the same size as Pluto. And we thought, well, what are we doing with all of those? Are they new planets or should we name them differently? So there was a bit of sort of question, what should we do with that? And then in 2006, we gave it the new title of dwarf planet. I see a quick question about Ceres here. Does it have moons? None that I'm aware of. And I do see the question as well about Pluto. We know 5 moons around Pluto, a big one, Charon, and then 4 smaller ones. There might be more that we haven't discovered yet, but there are 5 known moons around Pluto. So just to tell you quickly about the Kuiper belt, I mean, you've probably heard about the asteroid belt, right? This is something usually we learn, as we learn the planets, we learn about the asteroid belt as well. But the Kuiper belt, that's more recent, and it's not in all textbooks yet. So the Kuiper belt is a region very far in the solar system. Just think of it as a second asteroid belt, actually. But instead of being like rocky worlds, they're mostly icy objects and very far away. So in this drawing, here's the sun. This is the orbit of Saturn in green, and then Uranus in pink, Neptune in orange, the orbit of Pluto in yellow. You can see it's much more tilted compared to the other ones. Whoa. Whoa, I don't know what happened there. Everything went by very quickly. So yeah, the orbit of Pluto is very tilted relative to the other ones. And in this here, actually, this is pretty interesting. They show you the main probes that we've sent very far in the solar system. So the 2 Voyager spacecrafts and the 2 Pioneers, which were not manned, like there was no human on them. We just sent them and they're explored the solar system and they're very far away now. In 2015, the probe New Horizons visited Pluto here, and I'll show you some pictures from New Horizons in a few minutes. So yes, as you can see, the Kuiper belt is this region here. Many, many icy objects very far away. It's a bit like a second asteroid belt, but far in the solar system. So that gives you an idea of why we're changing the classifications. It's just because we learn new things, and that's how science works. We find things, we like to classify, understand a bit how things work. And then if we discover new things, sometimes we have to change our classification system. When Pluto was discovered, we didn't know there was a Kuiper belt. We just found Pluto. We just knew about one. Now we know there are many of them. So what is a planet? What is the definition today of what is a planet? And that's the definition that was decided in 2006. So that's actually many years ago already. That's 14 years ago by astronomers around the world. They decided that a planet would be a spherical object, so it needs to be round. it needs to be in orbit around the sun. That makes sense. That was probably what you were thinking about, right? A big round object around the sun. And it has to be sort of alone in its orbit. So I kind of simplified it saying it's not part of the asteroid belt or the Kuiper belt. So that's kind of obvious. Then what is a dwarf planet? Well, you can imagine a dwarf planet is also round. It's a spherical object, also in orbit around the sun, but it is part of the asteroid belt and the Kuiper belt. So if you're big round, but you're part of the asteroid belt or the Kuiper belt, you're not a planet, you're a dwarf planet. The name dwarf, you can see they're much smaller than the other ones, and they have to be small to be, like, if they were bigger, they would sort of clean their orbits. You wouldn't have so many objects close to them in their orbits, like being the asteroid belt or the Kuiper belt. So the fact that they're big enough to be round, but not big enough to sort of clean their orbits. So a way to simplify it is saying that they're part, and they are a part of the asteroid belt or the Kuiper belt. So these two guys that we saw earlier, Ceres and Pluto, are big enough to be spherical, and they're part, one of them is, Ceres is in the asteroid belt, this one is in the Kuiper belt, but they're now considered dwarf planets. Objects that are smaller than dwarf planets, they can have irregular shapes, they can be like big rocks, and those are what we call asteroids. But if they're big enough to be round, then we call them dwarf planets. So we have 5 dwarf planets today. There are currently 5 of them with the status of dwarf planets. I'm sorry, my face probably covers the dwarf part there. But there are most likely many more. So these are drawings of many of those objects. These are objects actually in the Kuiper belt. So we have Pluto with its largest moon, Charon, and 2 other moons. At the time, we only knew 2 more. Now we know there's 5 at least. So sorry, I don't know why it keeps doing that. So yeah, Pluto, Charon, and then we know 4 smaller moons. Eris here is the object that was discovered in 2003 that we know is about the same size as Pluto. And that sort of started the whole discussion about what should we do with Pluto and what should we do with Eris? Should we call it the 10th planet or not? And yeah, we didn't know what to do at the time. So in the end, it was voted to call them dwarf planets. So Eris is a dwarf planet. You can see it has a moon. Makemake is a dwarf planet. I saw this was a question. Haumea is a dwarf planet. Now you might say, hey, wait a minute, it's not round, it's not spherical. It gets a bit complicated. It's actually big enough to be round for its own gravity to make it round, but it spins so fast that it gets elongated. But it's still considered a dwarf planet. I'll just mention that. The other ones that you see here are not officially dwarf planets. They haven't been recognized as dwarf planets, but they most likely will be at some point. There are hundreds of objects in the Kuiper belt that could be dwarf planets. We just don't know if they're round. Because to be a dwarf planet, you have to be a sphere, and we don't know yet if they are because they're so far away. So for now, we only have 5 for sure that are spherical, and there we call them dwarf planets, but there might be more. Okay, I see a few questions here. I'll take a few here. How long does Pluto have to orbit around the sun to complete a full year? Or no, actually a year on Pluto is 248 Earth years. So it takes Pluto 248 years to go around the sun once. So it's pretty far. Is it possible for a moon to orbit the sun? No, because by definition, a moon orbits something that orbits the sun. And I said something because you could say a moon orbits a planet. That's true. But a moon can also orbit a dwarf planet. A moon can also orbit an asteroid. Some asteroids have moons. But if you're in orbit directly around the sun, you're not a moon. You're either a planet or a dwarf planet or an asteroid or a comet. There are more definitions. But by definition, a moon does not orbit the sun directly. It goes around an object that itself goes around the sun or a star. Is Pluto gas or rock? These are actually the objects very far away in the solar system are mostly ice. I'll show you some pictures of Pluto later, and you'll see that they have some rocks, but these objects have a lot of ice. So they're sort of icy worlds. We tend to think of rocky planets like the Earth and Venus and Mars and Mercury, and then the gas giants, Jupiter, Saturn, Neptune, and Uranus. I'm getting confused there. And then the other ones very far away are mostly icy worlds. And when I say ice, There's water ice, but there's also different types of ice. There's methane ice, there's nitrogen ice, ammonia ice. So there's different types of gases. These are usually gases around us here, are liquid, but if you go so cold, they become solid and we call them ice. And when I say so cold, it's because it's below minus 200 degrees on Pluto or around the Kuiper Belt. So pretty cold. Okay, I just want to show you quickly. I was telling you, sorry, I'll come back here. I was telling you that many more objects could be considered dwarf planets. I'll send you a link to a website. You don't have to look at all the details there, but it's basically a list of all the objects that could be dwarf planets. As you can see here, and they kind of put them in different categories, which ones are nearly certainly dwarf planets or highly likely or likely. And you can see there are hundreds of objects there. So when we say there are 5 dwarf planets, well, that's the ones that have been named dwarf planets now, but there are hundreds of interesting objects very far in the solar system. And this was a website that sort of compiles them. That was about a month ago or a bit more, how many of them we knew. So I'll give you the link if you want to check that. That's pretty interesting. Obviously, like Pluto, the big ones are here, but then you might have never heard of 2007 OR10, but it's probably a dwarf planet as well. Oh, and by the way, all those objects very far away, like the Kuiper Belt, just want to highlight some Canadian expertise here. There's a group out of Victoria and Vancouver that study these objects a lot, and they've found more than half of the objects in the Kuiper Belt were found by that team. So, we don't hear about that big discovery when they find a small object out there, but Canadians have found more than half of the objects in the Kuiper Belt. Many of them were done using the Canada-France-Hawaii telescope. And if you're a regular on Astro at Home, you've heard Mary Beth a few times. She's talked to us about different things. So she works at the Canada-France-Hawaii telescope. So they use that telescope to discover many objects very far away in the solar system. Okay, so what does it change for Pluto to not be a planet anymore, but be a dwarf planet? Does it change anything? Absolutely nothing. It's just for us humans how we name it. But sometimes people get confused with that. And I've had questions like, why is Pluto not in the solar system anymore? Well, Pluto is still in the solar system. The solar system consists of everything that's in orbit around the sun, right? So we have planets, but we also have asteroids and comets and dwarf planets, and there's a lot of moons in there too. So Pluto is still there. Its orbit hasn't changed. It's not like on the day we voted to change the name that its orbit changed and it disappeared or it went somewhere else or it shrunk, became smaller. No, it didn't change anything. Pluto is still the same. It's still out there. It's still a very interesting world. It's just the way we classify it, because as humans, we're curious. We want to know more. We learned more about the outer solar system and realized that it made more sense if we called it a dwarf planet, so that we wouldn't increase the number of planets every time we discovered something new in the Kuiper Belt. So I personally, sometimes I hear like, oh, poor Pluto, it's not a planet anymore. Pluto doesn't care. It's just a big cold rock and ice object very far in the solar system. It doesn't change anything to it. And it's still very interesting. It doesn't mean we shouldn't talk about it anymore. Okay, so now let's have a look a bit more at Pluto itself. So Pluto is pretty small. When we say it's a dwarf planet, you can see here, this is roughly the comparison between Pluto and the Earth. You can see on the image there as well, like it's smaller than our moon. So it is dwarf. It is quite small compared to other planets. And I mentioned that earlier. So in 2015, the space probe New Horizons flew by Pluto. When I say flew by, it didn't stop. It didn't go in orbit around it. It didn't land. It just flew by very quickly because it didn't have any fuel to slow down. This is something that's interesting when you start thinking about how things work in space. If you have, obviously that spacecraft left Earth, we had to give it a lot of fuel to accelerate and sort of go further in the solar system. But once it reached a very high speed, and I don't remember its speed, but it was going like around 30,000 kilometers per hour. That's very fast, maybe even more, tens of thousands of kilometers per hour. Anyway, I don't remember exactly. But anyway, once it reaches that speed, basically you don't need to give it more fuel to keep going. It's just, there's nothing to slow it down, so it will just keep going. So when it went by Pluto, it just kept going very quickly. We would have had to have brakes to slow it down, and that would have needed even more fuel. So we couldn't do that. So it just flew by very quickly, took a whole bunch of pictures, and many instruments studied Pluto as it flew by. And then all that data that was on the spacecraft, it kind of downloaded that to Earth, but it took over a year to download all the data because it's so far away and the signal was very, very weak. So it was not fast internet at all. But it took 9 years for New Horizons to reach Pluto. So it was launched in 2006, finally reached in the summer in 2015. And I know many of us, many scientists, or everyone curious about space was really excited that day because we were going to see Pluto up close for the first time. We had never seen the surface. It's so far away, even with the best telescopes on Earth, we could barely see details on the surface. So that was the first time we could see the surface in 2015. And it looked amazing. We didn't expect that. We thought it would be a world a bit like the moon, maybe like lots of craters, kind of grayish, more like a dead world where there's no interesting geology happening, geological processes. But turns out that Pluto is still active. There's some stuff happening under the crust there, and it's not fully understood how. We even think there might be an ocean underneath the icy surface that you see here. So I'll show you some pictures from up close. It's really, really beautiful. So first of all, this part here, you can see a lot of craters, but this one here has no crater at all. It all kind of looks like a heart. Or if you're imaginative a little bit, you can almost see the face of Pluto, the character from Disney right here, like the head of Pluto and the nose. Some people drew Pluto on top of the planet, the dwarf planet Pluto. That was pretty neat when it came out, but it kind of looks like a heart. Well, this heart here, it's ice, and it seems like there's a lot of ice coming from underneath the surface. And we know this is a newer part on the surface. Like Pluto itself is quite old, but there are new parts on the surface, which means there's sort of ice, not boiling, but kind of coming up from the center of from lower in Pluto and coming back up the surface, which was very, very intriguing. So let's have a look at Pluto from up close. I saw one of the question was, does it have mountains? Definitely. You can see a lot of mountains here. We'll see some up close as well in a minute. There you can see the transition from the, this is the sort of the ice field, and these are some of the mountains and craters. You can see how the ice probably even like spilled over and covered some of this area, like it went into this crater here and this one. So the ice filled these parts when it came up from underneath. Here's a close-up of that. Now this is pretty neat. We're looking at pictures, up close pictures from an object that is 40 times further away from the sun than we are. So it's extremely far in the solar system. And we're able to send a spacecraft there. It works super well. It was a real success. And we got close-up images of Pluto. Here's another region. This one is put in colors. And you can see the mountains. These are mountains a few kilometers high, and they are ice mountains. So they're not rock mountains, they're ice mountains. That's pretty cool. This part here is very weird. It looks like it kind of collapsed in the middle. Yeah, there were a lot of geological features there that were not fully understood. Here's another area showing some of the mountains and the ice and craters as well. Oh, look at that picture from up close of the ice field and then the mountains. Again, this is not on Earth, this is on Pluto. And the last one is my favorite picture of Pluto. It's sort of sunset on Pluto. So this is when the spacecraft, hold on, I'll take Pluto here again. So, as the spacecraft flew by Pluto, when it was on the other side, it kind of turned around to look at Pluto so it could see a bit of the sunset. The sun was on the other side now, and you can see the shadows of the mountains. And I had the question about the atmosphere. So I just I was waiting a little bit because I knew I would show this image. Yes, Pluto has a very thin atmosphere. We wouldn't be able to breathe, obviously. We wouldn't survive on Pluto. It's way too cold. There's basically no atmosphere, but there's just a tiny bit of haze, and you can see it here in the background. So yeah, I love this picture of Pluto. I think it's beautiful. And when the spacecraft was even further a little bit, it looked back and it saw basically a solar eclipse, except that what's blocking the sun is Pluto. So what you see here around, again, is the thin atmosphere, a bit of the haze there. and you can see the sunlight passing through it, but this is Pluto here blocking the sun in the background. So here's a solar eclipse with Pluto blocking the sun. Very nice. So yeah, Pluto is a fascinating world. I love talking about Pluto because I think it's very interesting, and the story of how it was named a planet and then the dwarf planet is very rich to talk about how the science works and how we change our knowledge as we change our classifications and the way we see things as our knowledge increases, and we always learn new things. There's always a lot more to discover. And in our solar system, even though it's still close to us, our solar system compared to other stars, we're just starting to explore the outer solar system. And these objects don't emit their own light. We only see them because they reflect the light from the sun. So it's very, very hard to see them. There'll be very, very faint point that we have to look at with a telescope. And the way we know they're not stars is if we look night after night and they've moved a little bit. But they're so far away that they don't move that much. Remember Venus? In the video I showed you earlier, night after night, you could see the motion. These objects are so far away that night after night, you might not see the motion. You have to look at over a longer period. So they're very hard to find. But yeah, there's still a lot to discover about the solar system. So I'm going to look at the questions because I see you guys had a lot, which is great. You can still send some. I'll see if I answered it. I won't talk about it because a lot of it is already in the presentation. So have we ever sent robots to Pluto? Again, we've never sent a robot on the surface, but New Horizons is the only spacecraft that's visited Pluto, and it flew by very quickly and kept going. So it didn't stop there, but we managed to get a lot of nice pictures. Is there water on Pluto? Yes, there is water. So there is water ice. And again, like I said, there's a lot of ice on Pluto. There's water ice, but there's also ice from different molecules or compounds like methane and ammonia. So it's not just water ice. We're used on Earth to say ice, it's water ice, but you can have ice from different things as well because it's very cold on Pluto. It's like, again, minus 220 degrees Celsius. It's below minus 200. And we think there might be liquid water underneath the surface, which was really a surprise. We didn't expect that so far away in the solar system, but it is one theory that there might be liquid water underneath, which I'm not too familiar with. This is like the latest results, and I'm not too familiar with those studies, but I find it very intriguing. Oh, where does the name Pluto come from? Pluto is the god of the underworld. Most objects in the solar system are named after god or goddesses in the Greek and Roman mythology. And the name Pluto was actually suggested by an 11-year-old girl from England. She suggested the name Pluto, the god of the underworld, because it was so far away, and they selected it as the name for Pluto. So it was discovered by a man in the United States, but it was named by a little girl in England. How long is a day on Pluto? I must admit, I don't even know. I would have to go check. So I'll look at the other questions and maybe I'll go back to try to answer that one. Are the moons of dwarf planets called moons or dwarf moons? I think they're just moons. I haven't heard anything about dwarf moons, but that's a very good question. And in fact, Charon, the largest moon around Pluto, sometimes it's considered a double planet because Charon is quite big relative to Pluto. So instead of having just Charon, okay, this one is Charon, this one is Pluto. Instead of having Charon just orbiting Pluto like this, they both orbit a common center of mass. So they both move a little bit. Pluto is bigger, but Charon is big enough to make Pluto move. So sometimes it's called a double dwarf planet system. Charon could also almost be considered a dwarf planet as well, but they still call it a moon. They decided not to give it the dwarf planet name, but it could be. Can a moon have a moon? We've never seen that. We've never seen a moon with, well, I don't know what it would be called, like something else in orbit around it. We've never seen that, but theoretically, I think it would be possible. Frédéric, yesterday in the talk, Moons and Exomoons, actually, if you weren't there, that was a very interesting talk. I invite you to go back on our YouTube channel and watch it. Frédéric mentioned, because that question got asked yesterday, and she mentioned that it could, especially when we find objects very far away around other stars. We found a moon, maybe an exomoon, so a moon around a planet around a star other than the sun, and the moon, that moon would be larger than Earth, would be about the size of Neptune. So that gets pretty weird, and maybe that object has something else in orbit around it. We don't know. Anyway, if that was confusing, because there's a lot of like a star other than the sun, and then planet around it the size maybe of Jupiter, and then the moon the size of Neptune, does it have something else in orbit around it? Go check out Frédéric's talk yesterday. She talked about it. What is the biggest dwarf planet in our solar system? Well, it's either Pluto or Eris. They're both very similar in size, and I don't think it's fully confirmed which one is largest between the two. Are there exo-dwarf planets? So those would be dwarf planets around other star. You know, like we say an exoplanet is basically a planet around another star than the sun. So an exo-dwarf planets, for sure there are some. We haven't discovered any because they're too small. They would be hard to discover, but for sure there are some objects the size of Pluto around other stars. Is New Horizons still able to send information back to scientists here? Yes, it is. And in fact, so it visited Pluto in 2015. In early 2019, it visited another object in the Kuiper Belt, MU69. It has official name now. I don't remember exactly what it is. But so we got pictures of another object very far away in the solar system, but it was much smaller than Pluto, and it's still going. It's still able to take pictures if it can, but it's, you know, it's a lot of empty space over there. If I come back quickly to the image, probably should have gone the other way around. That would have been easier. There we go. Okay. If you look at the Kuiper Belt here, it looks like there are, you know, if you were going to travel through it, it would be hard, you know, you would have to avoid objects, a bit like we see in sci-fi movies and science fiction movies. If you ever seen them fly through an asteroid belt, they always have to dodge, you know, to avoid the asteroids or the objects. Reality is that if you were in the Kuiper Belt, if you looked around, you wouldn't see anything. It would be dark. The objects in the Kuiper Belt are so far away from one another that you wouldn't see anything. So New Horizons is still going, and it might, I think scientists are trying to find if there's another object nearby that it could visit, because it can move a little bit. It can change its trajectory a little bit, but not by a whole lot. Like it can't change directions. So if there's something nearby, maybe it could adjust its course a little bit, but not by much. And maybe it will, you know, visit another object in the next few years. So dwarf planets, no, they can't be gas. I don't think you could. I don't think scientifically, physically, like you could have a dwarf planet that's only gas. It wouldn't work. You need something denser. So a lot of them, like I said, are ice or rocks. Ceres is mostly rocks, but also it has ice too. And in the Kuiper Belt, you mostly have ice, different types of ices on those objects. Again, they're too small. I don't think they could have rings. So that was a question here. Saturn is definitely not a dwarf planet. It is a gas giant. It's much, much larger. I like that. And I will tell you, are there any cool and mysterious stories about Pluto? So I told you that some scientists in Victoria are experts and they've found many objects in the Kuiper Belt. One of them is JJ Cavallars. And I used to work in Victoria, so I knew JJ, and he's sort of my reference when I have questions about the Kuiper Belt. You know, I phoned JJ and I asked him what the latest results were. So when I was asking them, I was at some point I was talking to him and I asked him, you know, about the composition of Pluto and understanding that it's really a new type of objects. We used to, you know, we always say there are terrestrial planets and then gas giants, but the reality is that we also have icy objects very far away, and that most of the objects in the Kuiper Belt are made out of ice. So I asked him, so basically, if Pluto was in a different orbit, instead of its orbit being almost a circle, if it was very elongated, like some comets, if it came closer to the sun and then further out, like orbits of comets are much more elongated instead of being almost perfect circles. I said, if Pluto was on a very elongated orbit, would it become a comet? Like, because it has a lot of ice, would that ice sublimate, like become a gas, and then you would see that tail in the sky? And he said, yes. So if Pluto was on a different orbit, basically it would be a giant comet if it came closer to the sun, because then it would develop a tail and we would see it as having this huge tail in the sky. but it won't happen. Pluto does not have that kind of orbit. It's in a stable orbit very far in the solar system. But if it came closer, it has the same composition as many comets. So that ice would melt and even evaporate, become gas, and it would reflect the light from the sun, and it would turn into a comet. So does that work as a cool and mysterious story about Pluto? I thought it was pretty cool when I learned about that. Did there used to be life on Pluto? We don't think so. Pluto is a very cold world, so we don't think there is life there. But again, it's we don't know for sure, right? We've never visited the surface. If there is liquid water underneath the ice, then there's some place interesting to study. We've talked about, again, Frédéric yesterday was talking about Enceladus around Saturn, Europa around Jupiter. These are two other icy worlds, ocean worlds in the solar system where we think there's liquid water. So these are extremely interesting when we talk about the search for life. We don't really think there are whole civilizations of aliens there, but maybe even just, bacteria or microbe or a cell would mean, there's life somewhere else. So that's very interesting. It's interesting to learn about those ocean worlds because we didn't expect that many years ago. We didn't think there would be liquid water far in the solar system, but turns out there might be some. I just want to finish here. If you have more questions, I can take them a few more minutes, but I just want to finish with an image. I think I did show it to you. Sorry, I'm going through my slides very quickly. I think I did show you that image like in week 1. That was, many weeks ago. But these are objects in the solar system. When we look at them, and I like this whole debate of, what is a planet? When you see these objects, which ones would you consider planets? Well, it's very hard if you just look at them, right? Because a planet has to be big enough to be round. So most of them are, actually all of the objects here are spherical. Some of them, one of them is a bit more elongated, but these are all objects that we know of in the solar system, which are spherical, and they are smaller than Earth and Venus. So there are actually 2 planets in this montage, and then everything else is either a moon or a dwarf planet or other objects very far in the solar system that we don't know for sure yet which shape they have. So if you want to know the answers, here are the names. So the 2 planets we have are Mars here and Mercury. So they actually took all spherical objects in the solar system smaller than 10,000 kilometers across. So that's why Venus and Earth would be just above that. Mars is there, and then Ganymede and Titan are the 2 largest moons. Ganymede is around Jupiter, Titan is around Saturn. Titan has an atmosphere. You can see that here. Actually, we're seeing the haze. We don't see through the atmosphere because it's so thick. Here's Callisto. You might not see it because my face is on top of it. Mercury, Eris, and Pluto, you can see that we have pretty much the same size. The reason Eris looks beige like this is just because we haven't visited it, so we don't know what it looks like. For this montage from the Planetary Society, which I really, really like this montage, I really like it. They put real pictures of the objects, and for the ones we haven't visited and we don't know exactly what the surface looks like, they only put this beige half circle. So the ones, like Triton's the moon around Neptune, we know what it looks like. Pluto, Eris, you can see they're pretty small compared to even our moon. And there you go. You have other ones like Sedna, we think is a sphere, but it's not. It's much further out, so it's very hard to tell. So we don't know, but it's one of the best candidates to be a dwarf planet. Here I was talking about Enceladus earlier. Enceladus, a moon of Saturn, and Europa, a moon of Jupiter. They seem to have oceans of liquid water underneath the ice on top. So these are very interesting worlds. So I like to talk about those because we tend to forget them, but I love the not planet objects in the solar system. And I think we should talk about them more. It's not because it's not a planet that it's not interesting. And same thing with Pluto now. Is there gravity on Pluto? Definitely there is gravity. As soon as you have an object, that has mass, there's gravity. I even have my own gravitational field, if you want, around me. It's not big enough to have things in orbit around me. And the gravitational field of the Earth is much stronger, obviously, so things fall down. I don't start orbiting myself. But as soon as you have an object that has mass, it has its own gravity. The bigger the object, the more mass, the more gravity it has. So on Pluto, there is gravity on it, but it wouldn't be you would feel a lot lighter. If you could travel to Pluto, if humans at some point can travel there, but that will take a long time, then they would feel very, very light on the surface. I don't know exactly what the surface gravity is like on Pluto, but it's probably less than like around, I don't know, I would say about 8% the gravity on Earth, something like that. Because on the moon, the gravity was about 16% the gravity on Earth. So they could jump 6 times less, basically. So they could jump a lot higher. On Pluto, they could jump even higher than that. Well, there you go. There, that was my presentation about Pluto. I hope it answered many of your questions about what is a planet, why is Pluto not a planet, should we even care? I personally think the whole process is interesting, but in the end, Pluto is a very interesting object, and that's what we should focus on. Look at the pictures of Pluto and learn more about it. It's a fascinating world, and that's what we should focus about. But the whole process is very interesting to understand how science works. So I hope that answered your questions. I hope you enjoyed learning about Pluto, and I'll put links under the video if you want to learn more. So thanks a lot, everyone, for joining us today. We're taking a 4-day break. We're not going to have any session tomorrow or next Monday, but we will be back on Tuesday with Jesse Rogerson. You might have seen him. He presented about Astro News a few weeks ago. I don't remember when. I don't even remember when anymore. But Jesse will be back on Tuesday to present something at Astro at Home. So thanks a lot, everyone, for being there. Thank you for joining us. Tell your friends if they want to come next week. We can have more people online. It's easy to have many people on YouTube like this. And we hope you enjoy these astronomy sessions. Thanks a lot, everyone. Thanks, Lindsay, in the background, too. Thanks a lot, everyone, for being there, and enjoy the long weekend.